Hello guys, welcome to Believe Education. In this video we want to talk about acids and bases. Particularly we want to look at the sample assessment questions that are in the module. That's module volume number 1 for combined science Zimsec. So before we start our lesson, we encourage you to subscribe to our channel as well as give comments so that we can understand what exactly is needed for your revision, so that when you get into your exam you just nail it. So not to waste much of your time, let's look at number 1. Number 1 says dash is an example of a weak acid. So here we have something called a weak acid. So a weak acid, a weak acid is an acid that doesn't completely dissociate in water. Are we together? So a weak acid is an acid that does not completely dissociate in water. So if a weak acid is one that does not completely dissociate in water, or that does not completely ionize in water, it therefore means that a strong acid is one that completely ionizes in water. So we also have let's look at the pH scale. It can also help us. So here we have 3 parts of the pH scale. We have 7 where we have our neutral, and we have 0, and we have 14. So from 0 up to 7 we have our acid. Then from 7 up to 14 we have our base. Is that okay? So acids are much more stronger starting from 0 maybe up to around 3. So here we have strong acids, and then as we progress, as we get close to the neutral point, which is 7, the acids become weaker. In other words, they do not completely dissociate or completely ionize in water. So we have weak acids, and then after 7 we have bases. Those bases are weak bases, and then as we draw more closer to 14 we have what we call strong bases. So that's our pH scale. And looking at our question required us to know which one of the following is a weak acid. So normally weak acids are those acids that are citric. In other words, we have citric acids being the acids that are called weak. So those acids that are weak, which are citric, in our answers, A, we have lemon juice. So lemon juice is part of citric acids, which are weak acids. We also have other acids that are weak. For example, orange juice. Again, orange is a citrus fruit. It contains citric acids as well. Then for our answers B, C, and D, we have nitric acid, sulfuric acid, as well as battery acid. So all those ones that are here, they are strong acids. So our answer for number 1 was going to be A. So we have to just keep in mind our pH scale so that we can understand the ones that are called strong acids, weak acids, as well as weak bases and strong bases. So let's look at number 2. The pH scale is divided into how many regions? The pH scale is divided into how many regions? So our pH scale, that's the one, and I could draw on the top. It is divided into 3 regions, and those 3 regions are the acid, the base, as well as the neutral point, which is 7. So our answer for number 2 is going to be B. Then we look at number 3. Solutions with a pH value of 1R. So we go back to our pH scale. If we have a solution with a pH of 1, it is going to be a strong acid according to that. So A, strong acids, that's true. Then B, alkalis. Alkalis are those ones that are bases. They are bases, so they have to be above 7. Then concentrated acids. So there's something you need to know about issue of something being concentrated or being diluted. Okay, so there is an effect that is there on acids concentration, or even the base concentration. So if we increase, let's say we increase the concentration of an acid, it becomes we can't really say it becomes strong. Yes, in a sense it becomes strong, but that doesn't make it a strong acid. Let's say, for example, we have a weak acid like lemon juice. Then we concentrate that lemon juice. If we concentrate that lemon juice, it doesn't become a strong acid. It just becomes concentrated lemon juice, but it is more stronger than the weaker one or the dilute one. And then we have weak bases. Weak bases is not our answer, because weak bases that goes for the pH of above 7. Then we go to number 4. Number 4, a strong base compounds dash. A, split fully when dissolved in water. Okay, so if it is a strong base or a strong acid, it dissociates completely. In other words, it splits fully. So A, splits fully in dissolved water, that's true. Then partially split, no, it would be weak. Then C, do not split, no. Then if it doesn't split in water, it means it's neutral. Then D, can donate away a proton. So if something can donate away a proton, it doesn't become a base, it becomes an acid, because an acid by definition is they are compounds that donate protons. In other words, they donate hydrogen ions. Is that okay? So going back to our question number 4, strong base compounds, the only answer that we have there is that they split fully when dissolved in water. So our answer is A. Then we look at number 5. Which of the following is not a product of the reaction between acids and carbonates? So we want to know the reaction between acids and carbonates. So let's just take an example. Let's say we react HCl, which is an acid, plus a carbonate. Maybe we react with sodium carbonate, and then this thing would then give us sodium chloride, which is a salt. Then we also have sodium chloride, and then we have H2O, which is water, and we also have plus carbon dioxide. So in our question, which of the following is not a product between acids and carbonates? So the basic products are salt, water, and carbon dioxide. So these ones were our basic products, which leaves sodium hydroxide solution as the answer iri odd, or in other words, that's the one that is not produced when we react acids and carbonates. So let's also look at the structured questions. Under the section, you may be expected to provide your answers in short notes in order to get the maximum point for your answers. So number 6, draw the pH scale to illustrate strong acids and weak bases. So this question, number 6, is then addressed with the one that we previously did. So in other words, we just repeat it. We have our pH scale here. We have 0, we have 7, and we have 14. Here from 0 to 7 we have acids. Then from 7 up to 14 we have bases. Then on 7 we have the ones that are neutral. So from 0 up to maybe a pH of 3 we have strong acids. Then from 3 up to around 7 we have weak acids. Then here we just divide again. From 7 up to maybe we say 12 we have weak bases, and then from 12 up to 14 we have strong bases. So that's our pH scale to illustrate the strong and weak bases, as well as the acids as well. Then we have number 7, an acid turns dash litmus paper to. So an acid turns blue litmus paper to red, and a base turns red litmus paper blue. We've completed that one. Then we have number 8, complete this chemical equation as a word equation. So we want to produce a word equation. We have a chemical equation. So in this question we're just basically identifying the chemical compounds that are there. So the first one here we have hydrochloric acid. So we'll then have to say hydrochloric acid plus the second one here is sodium hydroxide. Sodium hydroxide. They all give us this compound, which is sodium chloride. It is sodium chloride, then plus the last compound, that's water. So if we have done this, we have made the chemical equation to be a word equation. Then number 9, metals react with acids. Metals react with acids. So if a metal reacts with an acid, there is just a basic output, which is we produce a that's a salt plus hydrogen. So okay, so here we are asked to complete the table below. Okay, maybe for you to see probably we'll react, maybe for example we take magnesium plus an acid, let's say hydrochloric acid HCl, to give us magnesium chloride plus the hydrogen gas. Then what's left there is just to balance the equation. of which we're not focusing on. We'll focus on that when we look at stoichiometry and the mole concept. So, which in other words, we have a salt and hydrogen as the basic output inenge iripo kana reactor ma acids and what, and metals. So we are asked to complete the table below, which is this table. So reaction with acid is yes, it reacts, and then the reaction is vigorous. If magnesium reacts more than copper, so magnesium we have a more vigorous reaction than copper. Then for copper it's also a yes, and then it's less vigorous. Why? Because copper is lower in the reactivity series. Then the presence of gas bubbles. Yes, we have the presence of gas bubbles. What they mean by the presence of gas bubbles is that if we have a reaction that produces gas bubbles, that reaction is an effervescence reaction. In other words, it produces a gas. Then we have the effect of the gas on the burning, on burning splint. The gas that is produced is hydrogen. Hydrogen here is our gas that is produced. So hydrogen, when you put it on a burning splint, it will produce the same result. Since we have hydrogen and hydrogen, they'll produce the same result. Then that result is that the burning splint has a pop sound. It has a pop sound and it turns off by that pop sound. So the reason is that hydrogen is highly explosive. So when we place a burning splint on hydrogen, it will produce a pop sound. Why? Because it would quickly react and then it pops, then it switches off. Then name the gas that is formed for both of them is hydrogen gas that is formed. So thank you so much for participating in our video and listening. We hope that the video has helped you a lot, and don't forget to subscribe and support us in our channel. Thank you so much.